Concrete is cement, aggregate, and sand. You can narrow it down to 1920s to 1970s cement.
Everyone told us the $85 million Oak Island shaft was an accident of nature. But nature does not carve perfect angles. Nature does not repeat measurements with precision. And nature does not build like an engineer. This shaft does. One researcher noticed the detail everyone else ignored. Emma Culligan. She wasn't searching for treasure. She was searching for logic. And what she uncovered changed everything. The depths follow ancient engineering ratios. The construction layers repeat with impossible precision. The walls remain stable, where natural collapse should have destroyed them long ago. Every new discovery points to the same terrifying conclusion. Someone built this on purpose. If Emma is right, then Oak Island is not a mystery. It's a hidden construction buried beneath centuries of lies. And the deeper investigators went, the more the evidence stopped looking accidental and started looking intentional. By the end of this video, you'll understand who may have built it, why it was buried, and why some people believe the truth was never meant to reach the surface. So before we begin, subscribe now. Because once you see the evidence hidden beneath Oak Island, you may never look at this mystery the same way again. The structure of the shaft is where the natural explanation begins to collapse. Normally, sinkholes widen as they descend. Gravity drags loose material downward. Water erodes the edges, and the deeper the cavity gets, the more unstable and uneven it becomes. But this shaft behaves differently. It remains narrow, controlled, almost disciplined. Even more disturbing, the walls continue holding their shape through soil layers where collapse should have happened long ago. That alone is suspicious, but one overlooked detail makes it even harder to dismiss. The shaft keeps the same internal form even after cutting through highly unstable ground. Layers that are known for caving in unless some type of reinforcement is involved. And that's the moment geometry enters the picture. Because once geometry appears, the natural formation argument starts breaking apart. The shaft's alignment is unnervingly accurate. Not just vertical, but deliberately vertical. Small shifts appear only in places where pressure adjustment would actually make sense. These are not random imperfections caused by nature. They look calculated. The wall angles remain surprisingly consistent despite passing through sand, clay, and gravel, materials that normally react very differently underground. Nature doesn't carefully balance pressure changes. Engineers do. Emma analyzed the excavation data in a way nobody publicly had before. She compared the shaft to historical excavation designs from ancient mining systems, defensive tunnels, hidden wells, and pre-industrial access shafts. The similarities were impossible to ignore. The dimensions lined up, the ratios matched. Even the methods used to reduce pressure at deeper levels mirrored engineering techniques used centuries ago to stop underground collapses. A natural formation might accidentally resemble one engineered feature, but matching an entire structural system is something else entirely. Then investigators ran into another problem: the absence of chaotic widening. Natural underground voids usually become rougher and more unstable the deeper they go. This shaft doesn't. Its dimensions only shift at very specific points, and those shifts seem intentional. Small expansions appear exactly where pressure relief would be needed, almost as if the structure was designed with stress control in mind from the beginning. Erosion doesn't make decisions like that. Human planning does. And the deeper the investigation went, the stranger the evidence became. Along the shaft walls were faint markings, not dramatic cuts or obvious tool damage, just subtle grooves repeating in the same directions over and over again. At first, some believed water movement caused them, but water doesn't carve in measured patterns. These marks appear at evenly spaced intervals, beginning and ending with unusual consistency. Natural erosion creates randomness. This creates order. Emma focused on the spacing around the shaft walls, and what she found changed the entire discussion. The distance between the grooves remained nearly identical throughout multiple sections. That alone weakens the erosion theory. But the pattern became even more unsettling when compared to historical excavation tools. The spacing closely resembles the working width of tools once used to scrape and compact soil long before modern drilling equipment existed. The direction of the marks makes the explanation even harder to dismiss. Water cuts curved channels and irregular flow paths. These grooves move in straight, deliberate lines, consistent drag marks, controlled pressure, repeated strokes. And there's another issue almost nobody talks about. Water erosion doesn't simply stop on command. If flowing water created these marks, they would gradually continue deeper, fade naturally, or intensify near stronger flow zones. But that's not what happens here. The markings only appear in sections where the wall composition changes, exactly where a person excavating underground would need to adjust methods. Below those layers, the grooves disappear entirely, replaced by smoother, compacted surfaces that seem less eroded and more intentionally finished. That's the point where the entire argument changes. Now the question is no longer whether the shaft is unusual. The real question becomes whether it was deliberately constructed from the beginning, not discovered and reused, not accidentally formed, built. And if that's true, the implications become massive. It would mean someone understood Oak Island's underground environment well enough to engineer around it. It would mean the flooding systems weren't accidental intrusions, but expected obstacles. It would mean collapse zones may not represent failure at all, but design. Most disturbing of all, the shaft appears built to protect something below it. The precision preserved at those depths demands planning, labor, and intent far beyond anything a random natural collapse could produce. Structures like this are not designed unless whatever lies underneath is considered important enough to remain untouched. And that realization becomes impossible to ignore once investigators reached another critical layer. Deep underground, the excavation cuts into a dense clay band that shouldn't exist in such a controlled state. The clay is not scattered or blended naturally into surrounding soil. It appears in a clean, uniform section with consistent thickness, ending as sharply as it begins. Under normal geological conditions, clay deposits spread unevenly over time due to water flow and pressure changes. They do not form compressed, organized barriers like this. But this layer behaves more like a seal than sediment, almost as if it was placed intentionally to regulate pressure, isolate deeper sections, and preserve whatever remained below. Laboratory analysis only intensified the mystery. Tests suggested the clay had been compressed before burial, pressure applied while the material was still soft, then locked into place afterward. That detail alone creates a serious problem for the natural explanation. Water can shift clay, but it cannot uniformly compress it and insert it between stable layers without disturbing the surrounding ground. This clay layer doesn't look naturally deposited. It looks engineered. The clay layer doesn't just sit there buried underground. It functions almost like a seal, locking everything into place. When pressure builds from above, the layer holds firm. When pressure shifts underneath, the clay spreads and absorbs the force instead of cracking apart. That isn't normal sediment behavior. That's the kind of response you expect from something intentionally engineered. What makes the discovery even stranger is the effect this layer has on the shaft itself. Above the clay, the ground remains unstable and unpredictable. Moisture moves erratically, and the soil reacts constantly to pressure changes. But below the layer, everything changes. The walls become noticeably more stable. Water movement slows and balances differently. Pressure equalizes faster and more evenly. The clay isn't simply buried there. It's regulating the environment around it. And that introduces a chilling possibility. Whoever created this system understood exactly how water would behave underground long after construction ended. They weren't only building for the present, they were designing for the future. That idea becomes even harder to dismiss once investigators began tracking the shaft's water behavior over time. Water constantly enters the structure through rainfall, groundwater seepage, and seasonal pressure shifts. But despite all of that, the shaft never behaves chaotically. There are no violent floods, no sudden pressure explosions, no unpredictable surges. Even during storms that overwhelm nearby test sites, this shaft responds with unusual consistency, almost as though the water is being redirected somewhere else entirely. Emma focused on the flow data instead of speculation, and what she discovered changed the conversation again. The incoming water doesn't stay inside the shaft. Instead, it moves sideways through hidden pathways, escaping through concealed channels rather than collecting vertically. And these pathways aren't random cracks in the earth. When mapped out, they connect together with surprising precision, multiple routes feeding into larger, shared outlets. Nature usually scatters water in every direction. It spreads unpredictably. This system does the opposite. It gathers water, guides it, and releases it with control. The pattern closely resembles early underground engineering methods designed to prevent catastrophic collapses. Instead of completely blocking water, ancient builders often allowed controlled flow, giving pressure a safe way to escape. That's exactly what appears to be happening here. The shaft isn't resisting the water, it's managing it. Even more revealing is where those drainage routes refuse to go. Certain areas remain consistently dry, no matter how much moisture builds nearby. While surrounding sections show clear water exposure, these zones stay protected. That kind of selective dryness suggests nearby spaces were intentionally shielded from moisture damage. You don't create drainage systems like that unless something important is close enough to need protection. This structure isn't just practical, it's defensive. And then came the comparison that changed the entire theory surrounding Oak Island. When Emma compared the depth measurements from the $85 million shaft to historical records from the original money pit, the similarities became impossible to ignore. The major depth markers aligned almost perfectly. Resistance layers appeared at nearly identical intervals. Even more disturbing, both locations showed collapse zones that looked less accidental and more deliberate. Not failures. Design features. Controlled weak points that may have been created to absorb stress, redirect pressure, or trick diggers into believing they had reached the end. The similarities continue with the soil composition itself. Both structures use the same combination of compacted clay, layered fill, and strategically placed stone reinforcement. These aren't random geological coincidences. They suggest shared planning, shared techniques, maybe even the same builders. Natural formations do not repeat with this level of precision across separate underground sites. At that point, the explanation that the $85 million shaft was merely another collapse begins falling apart completely. Instead, the shaft starts looking like part of something larger. Not necessarily the treasure chamber itself, but a supporting structure designed to control water, mislead intruders, and protect another hidden location deeper underground. The money pit may have attracted attention, while this shaft quietly handled the real engineering work beneath the surface. And once that possibility enters the picture, the entire Oak Island story changes. The shaft stops looking like a strange accident and starts looking like evidence of a carefully planned underground network built specifically to avoid discovery. Because if Oak Island operates as an interconnected system rather than a random series of collapses, then confusion wasn't an unintended side effect. It was part of the design. That deception becomes visible almost immediately near the upper sections of the shaft. Closer to the surface, everything appears chaotic in the most believable way possible. Loose soil, broken layering, crooked alignment. Materials seem randomly scattered, and the walls appear unstable enough to convince experienced diggers they're looking at an ordinary collapse site. But the deeper excavation goes, the harder that explanation becomes to maintain, because the disorder suddenly stops, not gradually, instantly. Below a certain depth, the structure changes completely. The layers become organized again. The walls regain stability. Loose material gives way to compacted sections that feel controlled rather than natural. And in that moment, the illusion disappears. What looked random begins to look intentional. The lower sections of the shaft almost seem to cooperate with the excavation. And that sudden change is impossible to ignore. Natural cave-ins don't suddenly become organized. Once the ground begins failing, the damage usually spreads. But here, the instability appears controlled, almost staged for appearance rather than function. The disorder exists only near the top, exactly where early diggers would encounter it first. Loose soil above, structured stability below. That reversal feels less like geology and more like performance. The upper layers act like camouflage. They create the illusion that the shaft is unsafe, collapsed, or too unstable to continue exploring. Any early excavation team reaching that point would likely turn back, convinced nothing valuable could survive underneath that kind of chaos. And historically, that's exactly what happened. Multiple digs stopped at nearly the same depth, all citing dangerous instability. The deception worked because it matched what people expected to see. But once investigators pushed past that false layer, the real nature of the shaft began to appear. The structure becomes controlled again. Materials seem intentionally placed. Compression patterns show planning rather than randomness. The walls stabilize as if the builders expected future excavation attempts and prepared for them in advance. This wasn't just construction, it was psychological misdirection. And deeper underground, another strange feature begins to emerge. Stone groupings appear along the shaft walls. Not scattered debris, not fallen rubble. These stones are positioned at precise intervals, concentrated in areas where underground stress would naturally become dangerous. They aren't blocking tunnels or marking locations. They're carrying weight. Each cluster appears to redirect pressure away from vulnerable sections of the shaft. From a geological perspective, the arrangement makes very little sense naturally. But from an engineering perspective, it's remarkably sophisticated. When Emma mapped the stone placements, the pattern became impossible to dismiss. The system closely resembles ancient mining support techniques used before timber beams and steel reinforcement existed. Instead of holding the walls rigidly in place, the structure redistributes stress sideways, allowing the shaft to flex slightly without collapsing. Pressure doesn't move through the weak points. It moves around them. That kind of design requires a deep understanding of underground behavior, knowledge that supposedly shouldn't have existed in this region during that era. Even the stone sizes appear intentional. Larger blocks reinforce major stress zones, while smaller stones smooth the transitions between them, distributing pressure more evenly throughout the structure. The shaft almost behaves like a living system. Instead of resisting the earth, it adapts to it. That may explain why the shaft remains standing centuries later, while nearby excavations and test holes collapsed within only a few years. But as the mapping continued, the evidence became even more unsettling. The shaft extends far deeper than researchers originally believed possible. Deeper than historical records suggest people of that time should have been capable of excavating. Deeper than standard colonial mining methods normally allowed, and that changes everything, because the depth itself isn't just impressive. It challenges the entire accepted timeline surrounding Oak Island. When combined with the precision engineering, water management systems, and structural design already documented, the deeper levels begin to suggest something far older and more advanced than anyone expected. In fact, the deeper the shaft goes, the less likely it appears to belong to ordinary settlers or treasure hunters. Stratigraphic analysis places parts of the construction beneath layers connected to early colonial activity. That means whoever built this system didn't arrive and improvise after reaching the island. They came prepared. They already knew what they intended to build before the first excavation began. The level of engineering involved, pressure control, water regulation, controlled collapse systems, was extraordinarily advanced for the time. In some cases, it may have exceeded what was common anywhere nearby, and that completely disrupts the traditional Oak Island narrative. Because if this structure predates known settlement activity, then this was never just a hidden treasure site created by opportunistic explorers. It was a planned operation. Someone arrived at Oak Island with resources, organization, and a motive powerful enough to justify building an underground system capable of surviving centuries. Nothing about the shaft feels experimental. The pressure traps scattered throughout the structure operate like sacrificial defense points. They are meant to collapse first, preventing destructive force from reaching deeper sections of the underground system. In other words, the shaft functions like armor. Every cave-in historically blamed on bad luck or unstable soil may actually represent the defense system working exactly as intended. And that explains why investigators never found obvious treasure at the bottom. Because the shaft was never meant to store valuables. It was built to protect them. There are no piles of gold waiting below. No dramatic discovery chamber. No final reward hidden at the end of the tunnel, because revealing something valuable would defeat the entire purpose of the design. The shaft exists to discourage excavation, to convince intruders they've reached failure, danger, or a worthless dead end, while the real objective remains hidden somewhere else, protected behind layers of calculated deception. Thanks for watching. If you enjoyed this investigation, make sure to like the video, subscribe to the channel, and turn on notifications, because the deeper this mystery goes, the stranger the truth becomes.